Editing the human genome requires technology in order to change an organism's DNA. Genome editing allows for genetic material to be removed, added, and/or changed, essentially allowing researchers to target, cut, and fix a problem. Genome editing has gained a lot of interest due to its ability to potentially prevent human diseases. According to the editors of Encyclopedia Britannica in December of 2021, there are multiple experiments being introduced and conducted to demonstrate the editing of an organism's genetic material, including technology of the CRISPR-Cas9. Using this technology has been proven to be a more efficient, less costly, and more accurate way of doing so. The CRISPR-Cas9 editing process allows for a sequence of RNA to bind to a targeted DNA sequence in a genome. The DNA sequence then binds with the Cas9 enzyme, which cuts the DNA sequence, making room for repair, addition, or change. This editing method is most commonly used on cell tissue, also known as somatic. By making a change in the DNA, scientists can potentially prevent human diseases and illnesses. According to the 2017 NAS report, treatments involving genome editing are being developed called gene therapies. Gene therapies are therapies that are being constructed for disease prevention and treatment in humans. Germline therapies, however, although similar, are not the same, and these consist of changes in an organism's reproductive cells, which would then be passed down to that organism's future generations. Future generations are one of the biggest factors to consider when it comes to editing a human genome, especially when the test subject is a human. Germline editing could be an option in the future, provided that it is reviewed and approved by the FDA, CMS, FTC, and that it is regulated properly. Gene editing could potentially give parents the option to decide to remove disease-causing genes from their child's embryo, meaning that the child would be born without a gene-causing mutation, giving their children immunity as well. So as it is evident, germline editing helps prevent single gene disorders, giving us an effective way of eliminating the strong presence some of these diseases have and will have on future generations. Because this technology is still being developed, there are a lot of questions that arise about it, such as these. Is it safe? Is it ethical? And what are the cons to it? Scientists, researchers, and ethics committees like Eric D. Gray at the National Human Genome Research Institute are working to find the answers to whether or not this technology is effective and ethical for use in humans and on the human genome. As of right now, the CRISPR-Cas9 technology is being used for research within multiple diseases, more specifically single gene disorders like cystic fibrosis, sickle cell disease, and hemophilia, and many more. CRISPR can also contribute to prevention and treatment of more stubborn and complex diseases like cancer, HIV, and heart disease, as well as mental disorders in the future and muscular dystrophy. In 2018, reports from China showed evidence of gene editing experiments being executed by He Jiankui on twin embryos. Science.org reports that when the twin girls Lulu and Nana were born, they were announced to be the world's first gene-edited human babies with hopes of prevention of HIV. Many scientists deem the experiment premature and unethical, and Jiankui was sentenced to 14 years for illegal medical practices. And his attempt at making the girls immune to HIV had ultimately failed. When considering the endless potential medical advancements, the use of genome editing in research can largely increase what we know about disease treatment and, more importantly, disease prevention. When experimenting with somatic cells in genome editing, it's great because somatic cells are from a living organism and they are not part of that organism's reproductive system. When considering germline cells, it becomes a bit more of an ethical dilemma because germline editing changes a gene in an embryo, passing the gene down to that organism's descendants and so on. Once this technology becomes more accessible to aspiring parents, it could turn into a tool wanted for cosmetic adjustment purposes rather than a way to prevent disease and illness. This is when it becomes difficult for society to decide where to draw the line on experimenting with humans. This technology would also create an issue concerning population increase and population control, due to the amount of people that would be healthier and living longer. When addressing the human genome editing using CRISPR-Cas9, it is vital to pay attention to all aspects of life and opportunities for medical advancement. Although it is not ethical to do so and to experiment with editing the human genome, it could certainly be a key tool to a healthier, longer living, and more aware society, provided that procedures are properly regulated and executed. It is important to also note the ethical differences between experimenting on germline cells and somatic cells, as well as weighing out the possible medical advancements to be made with it and the risks of editing people's lives and society for future generations. If germline editing becomes a cosmetic adjustment tool instead of a way to prevent diseases, it will be a danger to society and future generations and the impossible standards that they will be held to. Not only will this create an economic class division between those who can afford it and those who can't, It will greatly damage self-esteem for those who cannot afford it. Until we can assess and resolve every possible outcome, we cannot make quick decisions without considering repercussions when applying this technology to humans. So in conclusion, gene editing is a great opportunity for medical advancement, but is not ethical because of the dangers of population growth, class division, and difficult societal standards that would be formed, concluding that the risk is too big.
Thank you. Did your research go in a different direction than you originally expected?
Yeah, so it actually did. I first started out thinking that genome editing, is like specifically on humans, was ethical, and I was going to argue why we should do it in terms of possible medical advancements that could be made. But as I looked further into it and did more research, my opinion changed on it, and I decided that it really wasn't very ethical because I started looking into germline editing as well.
Okay, thank you. What additional questions emerged from your research, and why are they important?
So obviously I had the question of, is it ethical, and what does the future look like for it? I also was going to look into the economic lens of it as well and think about cost and things like that, going into further the class division and things like that. But I couldn't find, as a lot of people couldn't, like the cost and how much it would cost for people to do and things like that, because it's just too far in the future.
Okay, thank you. Another round of applause.